In this video, we're going to learn about Venn diagrams, which is section 7D in the notes packet that I sent you guys. So to start, a Venn diagram is a visual representation of a set and any subsets of that set. And a Venn diagram starts with a universe. The universe is represented by a rectangle, often labeled U for universe. And you have to have that rectangle because that rectangle borders in the universe for you. Then inside the Venn diagram, there are various circles, and the circles represent subsets of that universe. So in this example, A is a subset of the universe. So let's do an example to kind of put this in context. Here is a universe for you. And recall from our previous lessons, this says that our universe contains the numbers 1 to 7, inclusive because of the equal signs, and that those numbers are from the set of integers, which means we're just talking about the numbers 1, 2, 3, 4, 5, 6, and 7. We're not talking about fractions or decimals that are in between those numbers. So this is a finite set. Now say that we have a set called A that is even numbers. Recall from our previous lesson, what would be the complement of A? If you said odd numbers, you are correct. All right, so let's draw this set. So the box represents the universe, so that's going to be it's going to contain all of the numbers 1, 2, 3, 4, 5, 6, 7. A is the even numbers. So here's our circle, which represents A, and into that circle, we'll put the even numbers. So 2, 4, and 6. Outside of the circles are going to be the odd numbers, 1, 3, 5, and 7. And we should name our universe U. So this whole thing, the box, the circle, the numbers, the labels, all of that would be the visual representation of the universe that was given to you here, and the subset of numbers that were evens, okay? So in the circle were the set of numbers that were even, and then because our universe contained numbers 1 through 7, outside of the circle, we had to put those other values, all right? Also recall, if I asked you for this, what am I asking you for? I'm asking you for the number of elements that are in set A. So how many numbers are in that circle? Well, there are 1, 2, 3 numbers in that circle. So there are 3 elements in set A. If I asked you how many elements are in the complement of A, well, those are the things that are not inside this circle. So 1, 2, 3, 4 values are outside of the circle, therefore the number of elements in the complement is 4. Okay, so just to think about what some things look like, some more vocabulary for you and what they look like. If you're talking about a subset, you have the universe, and you have A, which is a subset in the universe, and then a subset of A is another circle totally inside the universe. So in this case, we would know B is a subset, remember that's that little like sideways C looking thing, of A, because every part of B is inside A. Okay? Let's talk about an intersection. So recall from the previous lesson of the notation, we would have A intersection B. So our universe is the rectangle. We're going to have 2 circles. This one will be A. This one will be B. And think for a minute, what was the intersection? Well, the intersection was the place where the values in set A overlap with the values in set B. So when we think about a Venn diagram, we're talking about this place where the values of A overlap with the values of B. All right, let's talk about a union. Here's our universe, and here are our two sets, A and B. So A union B, remember the notation. A union represented all of the parts of A in addition to all of the parts of B. So in this case, we're talking about everything that's here in A and everything that's also in B, not doubling up what's in A already. Cool? All right, and then finally, if we had a disjoint or mutually exclusive, in that case, here's our universe. But disjoint or mutually exclusive, that means they don't share anything in common. So A is over here and B is over here, and they do not overlap or touch or anything like that. All right, let's go to the notes and look at example 6. So suppose our universe is these numbers. We want to illustrate on a Venn diagram the set. So there are two examples here. So let's start with A. We know our universe is going to be a box, so I'm just going to draw the box. Then I'm going to look at the two sets. Do they have any overlapping parts? And it turns out they do. They both have 3s, and they both have an 8. So when I draw my circles are going to overlap. Make sure you draw them big enough that you can write stuff in the circles. So what's in A? The numbers 1 and 6 are in A all by themselves. The numbers 2, 4, and 5 are in B all by themselves. Recall the highlighted green, those were the numbers 3 and 8. And then we have to double check, is that all of the numbers in the universe? Is everything accounted for? So we've got 1, 2, 3, 4, 5, 6, 7 was not accounted for. So 7 is out here. 7 is in the universe, but it's not in either set A or set B. Okay? So we're going to draw our universe. Then we're going to fill in A and B, asking ourselves, do they overlap? And then we're going to check the universe to make sure that all of the numbers have been accounted for. Okay, that being said, let's do part B. All right, so with part B, we have the same universe. And so we know we have a rectangle, which represents our universe. Then if we look at our values between A and B, do they have any overlapping parts? Yes, 3, 6, and 8 represent with 3, 6, 8. Ooh, and notice that B doesn't contain anything that's not in A. That means that B is a subset of A. So when I draw these, that's a highlighter. When I draw these, I'm going to draw A as a big circle, and B is going to be a smaller circle inside that. B is going to contain the 3, the 6, and the 8. A contains a 1 and a 7. And then lastly, we need to check the universe to make sure everything's accounted for. We have a 1. We don't have a 2, so that goes outside the circles, but in the universe. We have 3. We don't have a 4. we don't have a 5, 6, 7, 8, and that's it. So those are that's the diagram for part B. Okay, go ahead and try number 7 on your own. You can pause the video, and when you're done, come back, unpause the video to see if you got it right. Okay, if you're back, here is the solution. The universe contained the numbers 1 through 9 as integers. Set A contains 2, 4, and 8. Set B contains 1, 3, 5, and 9, so they don't overlap. And then 6 and 7 are in the universe, but not in either of those sets. Okay, great. I mentioned this in the last video, just as one last thing, because this is kind of important. Make sure you know what the special sets are. So remember what natural numbers are, remember what integers are, real numbers, and then make sure you understand these words, prime and composite. So remember, prime numbers are numbers like 2, 3, 5, 7, 11, etc. Composite numbers are not prime, so the composite numbers are complements of the primes. Odd numbers, even numbers, make sure you know those. Make sure you understand what they mean when they say multiples. So if I said multiples of 2, let's do this. Multiples of 3, that would be like 3, and then 6, and then 9. So basically that means you're counting by 3s. If I said multiples of 4, you'd be counting by 4s. Make sure you know what I mean when I say factors. So if I asked you for the factors of 30, I'm talking about 1 and 30, 2 and 15, 3 and 10, 4 doesn't have one, 5 and 6. So that's what I mean by factors. Okay, cool. That's it.